We're told that the vector O to A is 2A. We're told that the vector from O to B is 2B. We're told that M is the midpoint of AB. So this is one part, this is one part. We're told that N is on OB, such as O to N is 2 parts and N to B is 1 part. We're told that P is on the line AN, so here's P on that line, such that OPM is a straight line. And we need to use all of this information to help us to find the ratio of O to P compared to P to M, and then A to P compared to P to N. Right, to answer this question, considering that we know OPM is a straight line, that allows me to say that the vector O to P, is going to be some fraction. Now I'm just going to use the constant lambda for that, some fraction of O to M. So for example, if lambda was a half, for example, I'm just saying that O to P is half of O to M. Clearly it's not half here, I'm just using that as an example. But what I'm saying is the yellow line is some fraction of the green line. OP is some fraction of OM. I can also say a similar thing for the line AN. I can also say that A to P is going to be some fraction of A to N. A to P here is going to be some fraction of the A to N. And that fraction is denoted by the constant mu. If I can work out lambda and mu, that's going to help me to get these ratios. Right, to do this, we're going to pick a vector here and we're going to find it in 2 different ways. The vector I'm going to pick is going to be the vector O to P, I think. Doesn't have to be, you could do a different vector. It's just the one I'm choosing to do. And I'm going to do this in 2 different ways. So the first way I'm going to do vector O to P is going to be using what I've set up here. I know O to P is going to be equal to lambda times OM. So lambda times, now OM, what's my O to M vector? The O to M is from here to here. So let me do a bit of rough working out for that. O to M. That's going to be the same as O to A plus A to M. Now I know O to A is just 2A. And I know that A to M is going to be half of the whole of A to B. But I don't know what A to B is just yet. But again, I can do some rough working out to work out what A to B is. A to B is going to be the same as A to O, which is minus 2A, plus O to B, which is 2B. So now I know what A to B is, I can put that down, I can work out half of it, which will be my A to M. So I can now simplify this because I've got the 2A The half of the minus 2a is going to be minus a, and then the half of the 2b is going to be b. And now simplifying this some more, the 2a minus a is a plus b. So O to m is the same as a plus b. So O to p is some fraction of that. Right, I've considered O to p in one way. I'm now going to consider O to p in a different way. This way, instead of going from O to P, I'm going to go from O to A, and then I'm going to add A to P. Now, the O to A, I know that's easy, that's just the 2A. The A to P, I don't know what that is yet, but I know that's going to be some fraction of A to N. But I don't know what A to N is yet. But that's fine, because we can do some rough working out for A to N. I know that A to N, let me just clear a bit of space on my diagram. A to N is going to be the same as A to O plus O to N. A to O is minus 2A. O to N, well remember this is 2 parts out of the whole 3, so 2/3 of the vector 2b. Which we can simplify that's 2/3 times 2, which is 4/3 b. 2/3 times 2 is 4/3 b. So that's A to N. So A to P is going to be some fraction of that. We can simplify that. Let's expand those brackets. So we've got the mu times minus 2a. So that's going to be minus 2 mu a. And then we've also got the mu times 4/3 b, which is going to be 4/3 mu b. Now I can simplify this a little bit because I've got an a here and an a here, so I can factorise that out to get 2 minus 2 mu a plus 4/3 mu b. Right. Let's just remind ourselves what we've done then. We have found the vector O to P one way, then we've found the vector O to P a different way. They represent the same vector. So we should now be able to compare coefficients. So let's compare A terms. The A term here is just lambda, it's lambda times A. The A term down here is 2 minus 2 mu. Right, let's now compare B terms. The B term here is just going to be lambda times B, so lambda. the b term down here is going to be 4 over 3 mu. Right, notice that we have simultaneous equations to solve here to work out what lambda and mu are. Let me just create a little bit of space so I can solve these simultaneous equations. And then, once we know lambda and mu, we'll hopefully be able to answer the question. So let me just put that down there, create a bit more space. Okay, so I can take this and substitute it into there because I know that the lambdas are equal to one another. So I would have 4 over 3 mu equals 2 minus 2 mu. Let's simplify this a little bit by timesing both sides by 3. Add the 6 mu to both sides. Divide both sides by 10. So mu is 3/5. Substituting that back, let's substitute it back into this equation. So lambda is equal to 4/3 times 3/5, which is the same thing as 4/5. So mu is, we have now worked out that the lambda here is 4/5. And the mu here is 3/5. And then finally, let's just remind ourselves what that's actually saying. We are saying that OP is 4/5 of OM. This is 4/5 of the whole thing. So what that means then is this is 4 parts and this is 1 part. So the ratio OP to PM is 4 to 1. Whereas this is saying that AP, this is 3/5 of AN. 3/5 of the whole thing. Which means that this is 3 parts and this is 2 parts. So the ratio of AP to PN is 3 to 2. And we're done.